This meeting is recorded.
Um, the goal of this VI is to create a counter controlled by a push button and a stop button. When the VI runs, the counter should start at 0. After I press and release the switch, the counter increases by 5 every second. If I press and release again while it's increasing, it switches to decreasing by 2 every second until it reaches 0. Um, Let me move this out of the way. Can't hit play, hit the button. Turn that off because it kind of makes it run slower. We can see it's increasing by 5 every second. We hit the button, decreases by 2. Um, and if I press and release again while it's increasing, it switches to decreasing by 2 until it reaches 0. It must never go negative, and pressing the switch while decreasing switches it back to increasing. A stop button must end the program, and it goes back to 0. Overall, I chose an event-driven design using while loop plus an event structure. Here, it has oh, 3 different events: timeout, stop, and switch. Yeah, the while loop keeps the program running, and the event structure reacts to the user's actions and timing. Instead of continuously polling the switch, event triggers only when something happens, which is cleaner and avoids extra CPU use. To remember values between the loop iterations, I use shift registers as memory. We have a read and write that just continues. I use 3 shift registers: count, step, and done. Count stores the current counter value. Step stores the mode. +5 means count up. -2 means count down. Mm, and 0 at startup means no movement until the first button is released. Done is a Boolean and stops flag that becomes true, then the stop button is pressed. All 3 are initialized outside the loop. Count equals 0, step equals 0, and then done equals false. The timeout event uh, is the engine of the program. I set the timeout to 1000 milliseconds, so it executes once per second when no other events are occurring. In the timeout, I calculate count equals or count next equals count plus step. Then I clamp it by using a 0, using the max and min. So we only get the max side. So it can't go negative. The clamp value is written back to the count shift register and displayed in timeout, step, and done, are passed through unchanged because timeout should only update count. Um, the switch uses switch until released, which means the value change triggers twice, once on press and once on released. To avoid toggling on press, I use the event data new value down here. Oh, it's down here at the bottom. To control an inner case structure, uh, this case structure right here when it shows the when new val equals true, I press everything through no mode change. When new val equals false, released, I toggle step between +5 and -2 using equals and select. Uh, Pause. Yeah, equal and the select. And it sends the output. To ensure the mode only changes when the user releases the button, matching the assignment's wording. The stop button has its own event case. When the stop is pressed, the stop event writes true to done. Count and step press through unchanged. Done is wired to the while loop stop terminal so the stop exits cleanly and immediately. The biggest step in debugging was learning every event case must correctly write the shift register's outputs. If the event case accidentally overwrites count or step, it can look like the counter freezes and jumps. Also, I learned that max and min has two outputs and uses the wrong output can break clamping and cause weird behaviors. To debug, I used probes on the count, read write, step right, step read write, and done exactly to see what values were changing. And then also, I had issues with it would this, these wires to the count whenever it was different. I didn't have them all wired to count, so it would show zero every once in a while. That was kind of confusing. Overall, the VI works because it separates responsibilities timeout updates to the count on a schedule. Switch toggles the mode on release and stop ends the loop. Shift registers hold state and the event structure keeps the design organized and responsive. Mm, And that is the design for the LabVIEW VI Homework 3. And stop. How do I stop recording?